Hello guys, my name is Amit. So today we are going to discuss about Bookmyshow or Ticketmaster back of envelope calculations. So Bookmyshow or Ticketmaster both are online ticket booking platforms which are used to book the movie tickets. So we will cover all in all. This is a system design question. This system design question covers the requirements, both functional and non-functional requirements, back of envelope calculations. So basically there are two parts in back of envelope calculations, that is traffic estimates and storage estimates. That is how much bytes system is receiving per second, traffic estimates, and how much bytes system need to store for the span of 5 years or 10 years. That's the two calculations we do in back of envelope. Then usually what I prefer is that in high level design we do a one user calculation, that if one user is accessing the system, and then we scale this design from 100 to 1 lakh users maybe somehow, and then the database schema, and then I try to fit these things into the system. That system is scalable, secure, it should be modular, then system has a capacity to do logging, it should support load latency, it should have a cache validation, negative cache, it should be available, accurate, and it should analyze. Then it should be able to authenticate the users, it should be reliable, redundant, and it should be fast. But in this video we are just going to cover the back of envelope calculations. So back of envelope calculations and requirements, two things. So first of all, what are the requirements for online ticket booking system? So when the user logs in into the portal, let me open a new tab and let me just see bookmyshow.com. So let me just see simultaneously. Let us just see that how what happens. So what happens is that when the user logs in onto the portal, at that time it should show the movies in a particular city. For example, okay. For example, this is already selected, this NCR, but let the BMS or either Ticketmaster should have the option to select the popular cities. So let me select NCR. Now in NCR it should show, we since we are only talking about the movies, it should, if we go on to the movies tab, then it should show somehow this sort of filters, that the genre of the movie, Hindi, English, Punjabi, Korean, or whatever. And then let me click at any of the movie. So on click of any of the movie, it should give the movie reviews, uh, user reviews, some of the videos, some stories, and if I click on book tickets, then it should give the list of cinemas here and the timings here. So these are the basic requirements. And if I click on the show timing, do accept, then it should ask for the number of seats. If I do select, then it should show the theater layout. And if I do select two seats and select pay, then it should ask for a payment, and then it's it should accept the payment, and then I should receive the tickets. Okay, so the requirements are here. It should show movies in the city, then option to select country, state, city, and ask permission to detect the user location. This option I have already done, so that's why it was showing me this. Then it should show the theater names. So let's, for example, I have taken a Rambo. It should show the theater names, then the movie timings, and if I select any of the movie timing, then it should show the seat layout. Seat should be holded for 5 minutes only. After seat selection, it should take the payment and send ticket back either on phone or email. Okay, so now let us go on to the back of envelope calculations. So let me just do the traffic estimates first, that is number of connections served per second. So assuming the world population is this much at present time, somewhere around 40% of people are using internet, so it makes somewhere around this. Then booking tickets on Bookmyshow or Ticketmaster per month, I have taken 1% of this. This is just an assumption. So it makes somewhere these many users, 28 million users booking per month. Per day, I have divided by 20, I have divided by 30. So it will make it this. And per second will be somewhere around 625. Still, it is a high number, but we can assume that per second we will be getting these many connections. Okay. So what are the storage estimates for the use for the BMS or the Ticketmaster? So now the thing is that BMS or Ticketmaster will store photos, blogs, videos, and theater and user data. So these are the four categories. What I think the portal should be storing. Apart from that, it can store other data as well. Photos of the coming movies or maybe the past 1 month movies, blogs, and the videos, and the theater data. So let us just discuss what's the theater data. So every theater has a seat layout, right? This one. So every seat will have associated user, will have associated cost, and every theater will have variable number of seat layouts. So this is how it goes. Theater data, every theater information, that is name, address, number of seats, are stored inside the Bookmyshows database. Theater will be a base class. All derived classes are object of theater base class. So this is how this should be designed. That theater is a base class, something like this, and then out of it the other derived classes, each theater should derive. All derived classes are created at start of application, that is nothing created at runtime, because when we open a book my show, at that time all theater listings should be there. We cannot do it on the fly on the runtime, so we have to generate it using the early initialization, that is at the start of application only. So now let's see what each theater data should be there. So in a theater class, we can store the theater name as a string. So theater name can be max 30 characters. Um, any name it can be, right? It's just a name of a theater. So if it is a 30 character, one character is 4-bit long. Um, so in if we see 1 byte, uh, let me just see, one byte is equal to 8 bits, which is equal to something as 1234 1234, and we know that um, for 4 bits uh, can represent a one hexadecimal number. How? I'll just tell you that, because 2 raised to power 2 power 4 is 16, right? Yes, and in hexadecimal we have 16 characters, that is from 0 to 9, then A B C D E F. So hexadecimal number representation can be done using 4 bits. So that's how this calculation is coming, that one character will occupy 4 bits, 30 characters will occupy 120 bits, because one character is 4 bits and these are 30 characters, so 30 multiplied by 4, it becomes 120 bits. So this theater name will occupy 15 bytes. So 120 divided by, just a second, let me do 120 divided by 8, it becomes 15 bytes. So theater name per theater name will be somewhere around 15 bytes. Then theater state, in which state it is, it's a data I have taken, we can take it as a 15 bytes. Then theater address, including pin number, if we assume if it's at 200 bytes, then 200 characters, then it will take 100 bytes, same as per this above calculation. Then number of seats, this data will be um, this will be a random data. We can take for example, in C++, we can take boost any. In boost any, we can store any data at runtime in a boost data structure. It's an array which can store variable number of data at runtime. So now again I have taken seats as bool, because if I select any seat here, just I click here, so it will be marked as 1 if it is booked. If it is not, then it will be marked as 0. All initializations of seats are done 0. So this will be a 2D matrix. This is assumed, what this has to be uh, random, because different theaters will have different seats arrangement. Then each seat will have a user information structure associated with it. So every seat will have a user with it. If it is 1, if it is not, it will be 0. So what is the user information structure? So user will have a name. If it is a 30 characters, then it is 15 bytes. If it is an email uh, of a user, then it's 15 bytes. If it's a phone number, then it's 8 bytes. So overall, this theater structure for one theater will be somewhere around 6000 bytes. If we assume somewhere around 3600 theaters overall worldwide, it will be somewhere around 20 MB of data for storing the theater information. And I believe that this information is static, that is, um, a number of theaters getting new theaters getting opened and old theaters getting closed, it's same. So this remains somehow same. So for per day, this is 20 MB, and for 5 years also it's 20 MB, because I assume that number of theaters opened and number of theaters closed are same, so that's why the theater data is same. Then photos, for example, one photo takes 5 KB of data, and we have 1 million photos, not 1 million, somewhere 1 lakh photos at any time. So it will be 5 to 10 raised to 9 bytes, so it will be per day. And again for 5 years I think same data will be there, because um, when the new movies comes, the old data is deleted, and so on. BMS, or either Ticketmaster, will not keep all long old data. It will keep upcoming movies and somewhere I think 15 or 1 month past movies only. Then for blogs, one blog is allowed for 100 KB. So if we allow 1 lakh blogs anytime, then it will be this much of data. For video, if one video is taken as 1 GB and we allow 50,000 videos anytime, so it will be somewhere around this much amount of data, 5 into 13. So for 5 years, we have to add all these data, and it will be somewhere around 16 terabytes for 5 years. So at any time, website will have 1 lakh photos, blogs, 50,000 movies, that is these videos, and old data will be deleted and new data will be added. So I believe this is the back of envelope calculation for Ticketmaster. So that's all. I'll be discussing the high level design of Ticketmaster in the next video. If you find anything incorrect or any corrections, please do provide your suggestions. Thanks a lot.